Okay, we're going to move on to this one. Unfortunately, I forgot to record before, so some of it is already written, but I'm going to repeat them again. So we're going to have a reaction between barium hydroxide and acetic acid. And for this one, you need to balance them first. See, balance. Once they have been balanced, then you can move on. If you haven't balanced them, it's going to be very troublesome because the rest of your answer is going to be wrong. And then we're going to use a notation language here, which is mula-mula, reaksi, and sisa. Mula-mula is the moles at the beginning, and reaction is the reacted moles, and S is for the remaining moles. Because if you're still not used to this, you might not be able to see whether they are hydrolysis or buffer at the first time. So here I have two examples side by side, so it will be easier for you to determine whether this is hydrolysis or buffer. Now, this one is barium hydroxide 100 milliliters 0.1 m. The other is acetic acid 100 milliliters 0.2 m. And while this one is 100 milliliter each, but 0.1 m for base and 0.4 m for acid. Now here's the reaction. We're going to highlight this one first. First thing to do is note down all the known quantities. So this one, 100 milliliter times 0.1 is 10 mole. 100 milliliter times 0.2 is 20 moles. Put them at the beginning of the moles, 10 and 20. Now, which one we want to use? You need to find the ratio. So 10 divided by the coefficient, which is 1, and 20 divided by the coefficient, which is 2. So you have 10 each. Now, 10, both are the same. None of them is smaller, so you can use either one of them. Here, I use 10. Okay, I use 10, and remember, do not use this 10, but use this small. If I want to use the 20, I will use this one instead of this. This is just to find ratio. Now, you have 10, everything else will look back at this. 2 per 1 times 10 is 20, and 1 per 1 times 10 is 10, 2 per 1 times 10 is 20. Next, reduce them. 10 minus 10, 20 minus 20. None of them, at the beginning there's no product, so you just put this 10 to 10, 20 to 20. So here, no remaining moles at the reactant. Therefore, this is hydrolysis, and it's based on the strong one. The strong one will be base, because this is strong base, this is weak acid. Now, you're going to use the formula for OH, because the strong one is the base. It's Kw per Ka times molarity of the salt. And so Kw is 100 minus 14 per Ka is 10 minus 5, sorry. And the molarity of the salt is 10 per. Total volume is 200. Okay. You can scratch this, and I'm going to move here. So this one is minus. This is going to be minus 14 minus 5. So this will be 10 minus 9. And then this one, 1 divided by 20 is going to be 0.05. Okay. Next, you're going to do this, which is 5 times 10 minus 11. Or you can also do like this, 50 times 10 minus 12. Whichever you use will have same answer. So I'm going to use this one. Yeah, I'm going to use the odd number. So it's going to be root of 50 times 10 minus 6. Okay, then you will have POH. Yes, 6 minus log root of 50. pH will be 14 minus 6 minus log root of 50. So this is going to be 8 plus log root of 50. So that's the answer. You don't have to find the root of 50. If you can also just answer like this, it's already correct. If you want to have all in numbers without any log and any roots, it's also okay. Now, moving on to this one. If the barium hydroxide is 100 milliliter 0.1 and 100 milliliter 0.4. So put all the known quantity here again. 100 times 0.1, 100 times 0.4. And you'll have mula-mula, reaction, and remaining. This is going to be 10, this is going to be 40. Again, find the one smaller. So 10 divided by 1 is 10 and 40 divided by 2 is 20. So this one is smaller. Since this is smaller, we're going to use this. Again, 10, 2 per 1 times 10, 1 per 1 times 10, and 2 per 1 times 10. You'll have 20, 10, and 10. So, final result will be 10 minus 10, 40 minus 20, and this is 10 and 20. 20. So, as you can see, you have a remaining mole of the weak one. So, if you have the remaining moles, it's straight to be buffer. So, if this is buffer, look at this and see the weak one is acid. So, we're going to use this formula. So, this is going to be H plus equals to constant of acid times mole of acid per mole of salt. Put the constant of acid here. 10 to the power of 5 times the mole of acid is this one, 20 per 10. So this will go here while this will go here. Now final result will be 2 times 10 to the power of minus 5. Then since this is pH, you don't have to use 14 in it. The answer will be straight minus log 2 times 10 minus 5. So it's going to be 5 minus log 2. So now use this video for your final exam, and I hope this one is useful for you. Assalamualaikum warahmatullahi wabarakatuh.